Welcome to my talk. Thank you that you are all here, and it's always great to have a talk in a cinema. This is like the best equipment that you can have, and I fondly remember the Cinemax where we had all the other talks. I mean, the first stage is like way bigger than this, and you always felt like super small in front of it, but this is really something for a talk, right? It's always exciting. I'm curious to see the videos of it later. So, what I'm going to talk about today. Actually, my name is Stefan Richter. I'm the CEO, founder, and head of engineering from code.talks Technologies. So I founded the company in 1998, so it's over a quarter of a century old. And I started programming 43 years ago, in 1983, started programming on an Apple II in UCSD Pascal. Maybe some of you might know it. Some of you look like you might know it as well. And so I'm a programmer for over 40 years, and I started code.talks in the midst of the internet boom here in Germany, which was exciting times, especially in Hamburg, was like the hub of it, and we started building large-scale systems from that on. And at that time, I can tell stories where we had to build all the infrastructure ourselves, compiling kernels ourselves, and so we really built the infrastructure before we built the projects. But where we mostly got our reputation for is that we are very well known for delivering software projects on time, on budget, on target, and on quality. So we're very well organized. So we are an engineering company doing very low-level stuff if needed. But on the other hand, we are also very well organized. And today I want to talk a little bit about how we see a little bit, not how we see AI. I mean, many people predict like how is AI gonna be in like 10x years or in 5 years or tomorrow, I don't know. And actually I don't know either. Nobody knows, that's why it's so exciting. I think we just started in trying it out, how we can use it. And so I'm not going to talk about today about how to use coding agents or so. I mean, there's a myriad of talks and videos and people who show you like how to use cursor or whatever. I'm not going to talk about this. I'm more interested in how to use AI agents across the whole software engineering life cycle. So from idea to deployment of a system, and then also maintaining it and so, because a lot of the problems that we have to solve when you build systems at scale, like really large ones, it's not just a question of technology. It's not just a question of which code to write or the technical problems that you solve. The biggest problem in large projects is actually humans and communication. So first you have to figure out what you actually have to build, and then you have to build it, and you have to keep people on track to really continue on a journey to a deadline and deliver stuff together, even though people have different backgrounds and goals and experiences. So and how can we use AI for that? So not just for the coding, but actually for everything else. And this is what I'm trying to bring today. The interesting part is actually I also plan to do a lot of demos. So as you have seen, the internet here, the Wi-Fi is very flaky. So I had a chance to do some screenshots in the hall. So if my demos fail, then I have some screenshots. But I want to start with a system that we are internally using to run our own organization. So to organize all these people, so we are 300 people in Hamburg and in Lisbon, and we have over 85% of software engineers. So we really try to have like really capable teams who really know what they are doing, and then we organize them well and give them basically everything they need to run themselves, to really organize themselves and have like almost perfect information about the project. So in business cycles, you would say we have a digital twin of our organization. Of course, I wouldn't use this term, but this is basically what we have. We have a copy of our work in our system that is called Revolution. And actually, we're not just having a copy of the current work and the people and the projects and the interactions, but we also have stored everything in time series. So we can look into the past and say, like, how was this company looking like on 14th of February 2020? We can look at like which projects we had, who worked on what project, what was the state of that project. So we have really this resolution. So we have very, very detailed data about everything. So I want to show you a little demo of that going over in Revolution. So that's our tool. And let's see if it's fast enough now. So I just click around because I'm going to show you just a little overview and don't explain too much because we have a lot of data. It's very data-driven how we work. Just to give you an understanding, a little bit feeling what we have. And later I will show you also a concrete agent example how we are using it. But the main thing is basically every team has like an iteration view. So that's one of the teams of a large project we are doing for Lidl, which is one of the probably largest software projects in Germany currently. One of my colleagues, Michael Bohn, is giving a talk about it. How is that in such a large project with 10,000s of man days and like hundreds of people? How do you run that and how do you make this successful technically but also organizationally? So this is of course all the planning things that you have. We have a lot of metrics. I don't go into metrics. I could talk for hours about it. We started doing metrics up from 2015 on. And we have found a lot of really interesting things what you can do with them. Of course, here you also see like a board of things that what people are working on. But mostly you see the iteration view of each team is mostly numbers, like metrics and stuff like that. But also they have like a backlog. When you look into this here, you can see they have a backlog of all the modules. We call it structured backlog because in our backlog you can also have folders and you can open them and then you might have their markdown documents inside. So everything is basically stored together with the work that we do. So it's not just a backlog of stories and epics and stuff like that. We also have that. But it's also a backlog that contains markdown documents, checklists, and stuff like that. We have a checklist system, basically the same what aircraft pilots are doing when they check the engines, when they check pre-flight, after flight, before taxi, after taxi. We also do that. We conserve basically organizational knowledge in that. So this is what the people have. Like all the information is here. You can also have discussions on all these items. So it's a huge graph of things that we have. And to give you a feeling about that, I have brought a little video about it.
Every company is built on people. People with experience, knowledge, and ideas. As companies get bigger, this knowledge increases. Now imagine this is your company. Well, a digital twin of your company. This means it's a digital copy of your work. Everything you have ever created and will create is at your fingertips, accessible to everybody. Your team members, their interactions, project insights, iterations, milestones, epics, user stories, best practices, and results. Every information of your company is captured, structured, and evolves along with you. Everything you've ever done is available in one click. This digital twin helps you to learn from the past, grasp the present, and also to become better in the future. Let me explain. You have all company data available in one place, in real time and company-wide, giving everyone the same situational awareness. This makes you more efficient, effective, reduces friction, and ensures a high quality in all of your work. This team, for example, is just starting a new software project. They are gathering all product information and are working together with an AI agent to create their product requirements document based on predefined standards. Having all this data and knowledge available in one place is the best foundation for integrating context-aware AI agents. Because AI is only as powerful as the data and people behind it. Like this, AI becomes more than just a tool for your work. It becomes a team member that learns and contributes to the same knowledge as their human counterparts. This is amplifying our human capacities. We will be supercharged. And this is only the beginning of the future.
Yes. So I don't click around on the software, so I just give you a glimpse in what we have. So in our planning system, you saw we have like the backlog and we have everything in there, but we also have a knowledge base in there. So we started that a couple of years ago because we were growing, and I thought like we have to share our best practices to people. And at that time, it was easy to do it because you could just go over to somebody else at the same desk and talk about it, and you could basically just explain what we are doing. But over some time, it gets more difficult, and when you have larger projects and you onboard new people, then it's very tedious. So I thought like we should have a knowledge base where we can write down the articles that we have about best practices, and they should be very simple. So we don't write like 40 pages documents, but very small, bite-sized articles that you can read while you wait for the compiler or so. And with this, we have now a knowledge base with thousands of articles where everybody can contribute in our company, where we basically conserve our knowledge, and it's also organized with topics, and we have curators, and we have decision makers, which knowledge we put into our corpus of knowledge and share it with everybody else. And this knowledge basically is then used for onboarding new team members, creating standards for new projects and stuff like that. So, and of course, this means everything that we do is also written down and very concise and also very clear language, which is also makes it very usable for AI agents. We did this before we started with AI agents, actually. So you can see here, when you drill down in the knowledge base, you see a software engineering basics. One of the most important articles here is simplicity, use fewer parts. It's like we are very much about making everything as simple and as uniform as possible when we build something. And you can also see here that the knowledge base also contains AI agents. So we have a knowledge base that contains knowledge base articles as markdown documents. We have checklists, just like in aviation, and we have agents in that system. And these agents can read and write everything that is in this system. So you can see here, for example, there's one metric agent that analyzes your metrics and advises you on how to find and remove friction, one of the tasks that people in our company are doing. Okay, and then you see metrics. I don't go into the metrics thing. If you're interested, you can later ask questions about it. But actually, before I come to the team member that we want to build, is actually the question, what is a team member then in the end? Is this somebody where I just offload work and they will work just do the work that I should do? Currently, I don't see that this is existing. This is not the state of AI that we have reached. If we are at that point in time, this is probably AGI, and then we are basically all in deep shit, I think. But until now, we have like very capable agents that you can use for specific tasks. You can also use them to do like really one-shot things where you build like something really interesting by a simple prompt. But when you work in a team that creates millions of lines of code per year in a large project with hundreds of people, this is not something you can just prompt. But there's many things you have to do before you can write code in a large team, in a large system, and this is also maybe where you might want to use AI. But of course, you don't want it to just say like, oh, please generate me all the artifacts that I need to do my work, because we know we cannot just trust what AI does. You always have to check the results, so you should be capable of what you're doing. So to better understand how we solve this problem for us, I want to explain a little bit how we see the world, how we actually see performance, and how we can improve performance with AI agents. Because if I want to use AI, they should have a purpose. They should make us faster or better in some ways, and we have to figure out what that is. And it's not just generating code. So for us, it's important to explain what is our definition of performance and how do we lead people, and how can then AI become part of that team that we are leading. So what is the definition of performance in our company? Performance is basically effectiveness, so what you do, basically which features are you implemented, that you work on the right things. That is, being effective means you work on the right things. You're not effective if you work on things that are not important, that are not needed to solve the problem at hand. So we want to be 100% effective, to do as much as possible, working towards the solution we want to deliver until the deadline. And this then multiplied by efficiency. So efficiency means that you don't waste resources like human time or other resources like compute resources, stuff like that. So you want to make everything as efficient as possible. You want to use as few times or as low amount of time as possible to solve a problem. But of course, if you think like, okay, work on the right things and make it very efficient, so don't waste any time, make it very fast, you also have to keep in mind that you also need to bring this to a level of quality. So you have to multiply effectiveness and efficiency also with quality, because if you have no quality, it doesn't matter how efficient or how effective you are. So you need all these three things, and when you multiply it, you can understand from the equation, this is basically our definition of performance, is like when one of the variables is 0, then basically you have not won anything. If you are super efficient, but you work on the wrong things, then you have not won anything. It's like really you have to really balance this equation. And the core definition, effectiveness multiplied by efficiency, that's what we see what productivity is. So, and then, for example, if we ask, how do we use AI? What are we getting better now? Can we do like, can we become more effective? Can we become more efficient? Or can we have a higher quality? Then we have also two other definitions that are important for us when we talk about performance. So performance is something where we say when something is nominal, we think this is actually how we want to be. So this term comes from aviation and spacecraft. So when you are a SpaceX fan and you like rockets, then you have often heard like they say all systems are nominal, which means all systems are within expected and accepted parameters. So what is accepted and expected parameters? So for example, in our company, or you can do this yourself, you can define nominal values for anything. You can just define, what do you think, how much time should a programmer spend on programming? Any guesses? Any numbers throw in? How much percentage of the time of a programmer should people write programs? 10%, 30%, 40%. Yes, you see, we have different definitions of it, and that's totally okay. You can define how it is in your organization, because this is also what we do. In our company, we think it should be 65%. This would be like elite nominal performance, but it's very difficult to get to 65% because you have to talk to humans, figure out what you build, and then do it and talk with your colleagues. And so there's a lot of things that you also have to do. So you cannot just write code. But of course, you want to optimize it. You don't want to end up with being nobody knowing how much time they spend on programming, because you want to optimize it. And this is why we defined in our company, for everything we want to do good, we define a nominal value, something where you think like, this is how we should be. For example, another nominal value is like, we should have 5 engineers maximum in a team. So we want to have small teams. And this is also a nominal value then. But then often, so nominal is like we want to be at 65% of development ratio, how we call it, but we will not always achieve it, because in the beginning of a project, you have to do more meetings to figure out what you do. You start planning, you're onboarding members. So there's more, more things than just programming. So that is basically then not preventable. You have to start somewhere, and then you're maybe only 20, 30% in the beginning when you're ramping up. But this is what we call then the optimal performance. So optimal performance means this is what the best we can do under these circumstances, because you cannot prevent it, you have to do it, but your goal is still to get to 65% of performance. So you try to understand what is nominal, and then you find your optimal way under the circumstances, but you still try to figure out how you get closer to nominal performance. So that's basically the summary there. Nominal is within expected and accepted limits. And optimal is the best we can do under the circumstances. And often people say like, yeah, everybody should have peak performance. So peak performance is something that you should do and will do at a certain point in time, but you cannot do it over long periods of time. So maybe you have an incident and your system broke at night. Of course, you stand up, you fix it, you work until it's fixed, and then you go home. So, and this is maybe then a peak performance, or you have to deliver something and you have to finish something to a specific deadline, and or something bad happened and you really have to jump in and do it, then you do it. This is peak performance, but you cannot do this over longer periods of time. So we really look for nominal and optimal. So when we start a project, we really first define also an optimal work environment or a nominal work environment. We say like, this is how the organization should look like, where we deploy our teams. We see this a little bit like a jungle. So a jungle is like lots of trees and like dangerous animals and stuff. And we really have to put a clearing into that jungle, which is basically the organization we are working for. Mostly we are working for very large organizations that are very complex and complicated. And we have to be simple and easy, but we have to do a clearing inside the organization to make sure that our teams are not overburdened with bureaucracy and stuff like that. So this is how we see it. And we also have rules for that. We have like nominal work environment definitions. What is a good work environment? And this is, for some examples, we want to have like 1 PO per team maximum. So sometimes people come to us and say like, oh, we have 3 POs and they are all part-time. They say like, no, we want 1 but full-time. So because it's better to talk with 1 person than talk with 3, to keep things simple. Or team performance, we think a good commit should be about 250 lines of code. Why? Because it's easy to do a code review, and then you have faster commits. And so if people have like 5,000 lines of commits, it's very difficult to review them, and maybe the changes are not done because it's already such a hairball of code that nobody dares to change it anymore. So this is what we mean like with nominal performance definitions that we have. And then like team performance, at least 65% of the time writing code, or like a team having 5 engineers. So that's some examples of performance then, and nominal and optimal. And so we have like, that's not that important here, but we have an engineering level pyramid where we teach people basically to start like being able to build and implement one user story and being really good at it and deploying it, understanding the code base, estimate your own time, do this. And then we teach you like in our engineering levels, we have 14 different levels up to staff engineer. We get more and more experience on how to run larger projects. And this is also where AI comes later handy, is like, because when you run a large project and you're responsible, an engineer, for 10,000s of mandates and millions of lines of code, you need to get an understanding of what is actually happening, because you cannot talk with everybody anymore. And I will show you later an example of that. So now we get to, I talked about performance because the AI should also help us to get to better performance. But how do we lead our teams? Because if you find something where you want to optimize performance, you have to somehow bring it into your organization. As a team lead in a small team of 5, you have to lead that team and you have to bring change to the team. If you are a staff engineer and you work with several teams in our company and you want to bring change, that you have to work with a group of people. And when you're responsible for many projects, you have to do this as well. Or I am running the whole company. If I want to do a change, it ripples through the whole organization. So how are we doing this? How do I bring change to my organization? And we do this with a thing called Auftragstaktik, which is actually a very modern management philosophy that was actually perfected by the Prussian military in 1800. They were able to run very large organizations with 100,000s of soldiers very efficiently. And obviously, you can learn a lot from military as well, because the organization of a large group of people, and the goal is also that few or as few people as possible die and you win. Obviously, you have to do something wrong to make that happen, something right to make that happen. So you can learn a lot from that. And basically, this is something that's also copied now around the world across all militaries. It's a decentralization of authority using mission tactics. That's how you call it in English. So all modern militaries are working on by these rules, and they're very simple. Basically, what you do is you really define a very good goal and intent. Maybe also see why I'm saying this, because AI also needs a good goal and intent. And then you are tasking a team. So what we want to do is basically push down authority to make decisions to the lowest level practical. So we really want to just tell people, this is the goal, this is the deadline, this is the scope. Also, they figured out the scope themselves, so not somebody else is doing estimates, this is all done by the team. But basically, they have a very clear mission, and then they go in and get the task. And we also provide a very good intent. So why are we doing it? Because The why is very stable normally, but the goal in itself can be malleable. It might change even, but the why you are doing it might not. And then people also are able to do decisions themselves better. And then, of course, we provide flexibility how to solve this mission and the intent within predefined limits. And the predefined limits, you guess it, are in our knowledge base. So like military, obviously, there are predefined limits, for example, Geneva Conventions or stuff like that, or you don't shoot your own people, stuff like that. In software engineering, it's different. So of course, you have specific rules maybe on what kind of programming languages you use or how languages are used, how you access databases, how you do batch processing, whatever, technical things, but also organizational things. And so these are the predefined limits that our people know because they are in the knowledge base. And also people can improve the knowledge base and write in the knowledge base and can improve what we have and also deprecate old knowledge. Of course, a precondition for that to push down authority deeper down into teams requires that the people have the skill, so they can really do it. They're really good at it, what you want to have from them. And then the will, so they really have to want to solve the problem and really want to be part of that. And this is also an important thing we often see in companies that they have teams and they only give them a list of tickets. So people just go in and do tickets. I think this is a very, very sad life if you come in the morning in your office and there's just a batch of tickets waiting for you and you have no idea who's using it, why it's there, what is done with it, why it's important. And so we really want people who are interested in that as well. So what we then need to really run this project is situational awareness. And this basically, when you see this, you have a goal and intent. On the left-hand side is coming in, and in the middle is like human action, the people who do the work, our teams doing this. And they, from below, they get like the predefined limits, standard, the current state of the project, which we see like a world model of our world, of our project. As I said, like the digital twin of the project that we have. And of course, the mindset of the people, the will that they really want to solve this problem. And then you might get a result, a desired end state that fits with all this together. But of course, from the top, you also get the independent will of other actors around you, like your customer you're working with, other teams you're working with, the world around you. This is also human action, and you have to make sure that everybody's on the same page, that everybody understands what should be done and why. And so this is kind of a recursive problem. If you work in a large organization, you cannot only make your team know as much as possible about the work that you do, but you also have to give this information to everybody surrounding you to get a better result in the end. So, and of course, this is also, all the things we do here is actually also the base how to use AI. Because what I see today is of people say like, oh yeah, let's employ a coding agent, and then they have a coding agent. And then you figure out, okay, but it does have to understand the code base. So I need some kind of context. I have to write down how is this code base meant to be, how it's structured. Of course, it can analyze the code base, but what you actually want also is to tell it what your intentions were. And if you write too much, it might get confused. If you write not enough, you get bad code. So, and the same is also true when you use AI in any other places besides code. If they don't know what to do, if they don't know the goal, the intent, and the predefined limits, then they will not be able to support you with like interesting AI functionality. So this is why the most important thing then in the end is to create this situational awareness around everything. So just as an overview, like what we do is like we write down goal and intent, this kind of a mission briefing, and the tool for us is the Auftragstaktik. Then we have predefined limits and standards, that's the knowledge base, and this articles and checklist, and then we have the current state of the project, this is a world model and the metrics around it, which is basically partly are these product requirements documents, milestones, epics, stories, tasks, everything like that, the code of course. And then, of course, the mindset that we also bring to the people when we onboard them, and the peer feedback that is done in our organization. So, and then with all this, now we come to the final point of how we employ this with AI. What we want from our people is basically to constantly find and remove friction. So friction is actually all the things you don't want to do in a project, that you don't want to do because they make you slow. They don't pay onto the result that you want to create. So you want to constantly improve the performance of the team by making them more efficient, removing stuff that you shouldn't do. So efficiency is not just about being like working faster, it's basically removing things that you shouldn't do in the first place. And also teaching people how to do that. And one way to teach this to people how to do that is actually the OODA loop. So the OODA loop comes from fighter pilots. This basically, when you're flying in a jet, this is how they teach fighter pilots how to think. So it's 4 steps. The first step is like observe. You should observe. Basically, the question is what's going on. So you gather data about the environment, and you try to have like a constant situational awareness what's going on around you. Then you orient yourself. The question that you have in mind is like, what does this mean, what I'm seeing here? And you try to integrate this new information with your prior experience as a human, the training, the education, the mindset, your cultural background, your family upbringing, whatever. And then you try to create a continuously evolving mental model by constantly filtering the reality. And when you have done that, then you can ask yourself, what will I do? So you decide now. And from your orientation that you have done, you generate and select from several possible actions. And then you act, you do it. And when you have done it, when you have made it happen, then you immediately feedback the results into your next operation phase, creating a self-correcting feedback loop. So, and this is what you can also teach agents to do. So when you have all this information, when you have like really this thing, like an API to your world model, like for us it's like product requirements, documents, epics, stories, tasks, checklists, discussions, everything we have in our system. This is the API. And then we have the knowledge base that explains you basically how to interact with the world model, how the world model is meant to be. What is a good state of a world model? What is a bad state of a world model? Basically, when you have this written down, then you can put agents on top of it. And this is actually what we have done. We have had all these other things before, and then beginning of this year, we started to put agents as top-level objects into this system, into Revolution. So now I would do a demo. I hope it works. Maybe we watch the film. I don't know. There's Revolution. So make it a little bit bigger. So I go to the knowledge base, and here you see like AI agents. And here, for example, you see many different agents like crafting a product requirements document, plan milestones based on a PRD, so you can use the input. So like one step generates a PRD based on standards that you have written down in the system prompt, and it generates a knowledge base article document as a PRD that you can then use to plan milestones on top of it. Then we have an epic agent that breaks down an epic into its user stories. And of course, these are all agents that you can use in a dialogue. They start this process, and then you can work with them together to create the results. And in the end, they will ask you, should I store this? Should I store this new story? Should I store this as a knowledge document? And we have a metrics agent that analyzes your metrics, which is also kind of interesting. So I explained first principles, what is good. And then actually I explained a little bit like a little formal language based on behavior trees and a little Lisp syntax to make it basically reason over the data that we have. And it's also an interesting idea to just with natural language define a formal language and then use that as explanation. This also worked quite well for us. But the most interesting one I want to show you, where we am currently working on, is basically this agent here that does the OODA loop. So it's the OODA agent that does observe, orient, decide, and act. And maybe let's make it a little bit bigger. It's not so important what's written there. But every agent in this system, of course, has like a description that humans can read what this agent can do. And it explains also here the OODA. And then we have here, I wrote a little system prompt, and it's also very friendly and funny, and it starts with a cowboy quote, something a jet fighter pilot might say if you were talking to a human. And then it will ask for a team, and then I explain what it should do in the ORDER loop. So it's not a big system prompt. And currently we only work with Gemini models to link them here, but of course we could integrate anything. And then we have lots of tools what the system can access, and you can select from them. So, and I give you one example conversation. This is like here what we had. So it's basically saying like, howdy partner, this here's your flight lead speaking, I'm ready to roll. Let's make sure our instruments are calibrated. What team are we looking at today? Can you drop a link or add mention them? So, and then add mentioned. So of course everything you can here add mention and inspected. Let's look into Vavi year-end, which is one of the teams. And they said, all right, partner, I got my eyes on Vavi year-end project. And then does it sound like a plan, or should we abort the mission? So it's always telling me what it will do in the next step. And I could also now chat with it and tell it maybe also to change course or do different things or incorporate other information as well. And then it's basically using the tools to looking up the iterations. You can inspect them here, get the data, loading the metrics. And then it does a summary of it. And I told it to do a simple table. So, and then also you can look at the data here. And then it gives you a summary, basically what it has done. And now it tells us, okay, I do the analysis now. So next step is the orientation after getting all the data. And now it's explaining basically some metrics that we use, like planning reliability, estimate deviation, which all looks good here in that team. And then also other things that should be tightened up, other metrics that we have. And it was able also to look into the knowledge base, reading the documents that we have there. And then it says, like, okay, this is a summary. Next step, I make a decision table. So to create top 5 list, are you ready for it? Or you want to review the intel first. So I could still interact with it, but I don't. And then it's giving me like a list of things it could do. And then it's time to act. Now I'm curious, and it gives me the final advice. And I can take all this analysis now, and it's asking me in the end, would you like to store the result of the analysis and advice in a new knowledge-based document for future reference? If so, please tell me which folder it should be stored in. And then I can just add mention the folder, so I can just type ahead. Say like, yeah, store it for future generations. And he's creating the knowledge-based document, which is basically then an inline form, which is quite nice because in this chat window, we now use the forms that we have in our system, and you could still edit it before you click save. Of course, I clicked save already. This is why it's disabled, so you cannot change it anymore. But I could also change that document. But once I have saved it, scroll down. Then it was approved. I can also say, no, don't save it. And then they say, okay, I stored it. You can find it here. So I can click on the document. And then I later asked to generate the document again, and said, like, here it is. You don't need to generate it again. But yeah, that's an example what you can do now. And when you look at this document, I can click on it, and you see the document here. That's now interesting because now I can use this document as the input for the next loop. I stored the result of this analysis with this agent, and next time I run this agent, I tell it, okay, analyze the iteration of this team, but also incorporate the last analysis that you did. So this creates like an interesting loop, and of course there's many optimization things that you can do if you have many documents, you want to summarize them and so, but this is the work we are currently working on, that we give these tools basically to help people to get a good understanding of the project they are working on and find and remove friction in their organization. And that is basically the end of my talk.